we know that segmentation is a hard problem. So the question is, how do we humans accomplish it? So let's take a look at this example right here. In this image, if you stare at it long enough, on the right here, you will ultimately perceive a dog, right here in this region. And once you perceive the dog, then you're able to identify its various parts, the feet, the tail, the head, and so on. So this is what's referred to as the Gestalt theory of visual perception. It's a group of German scientists who came together and developed this theory. Gestalt, by the way, is German for form or shape. And this theory says that what we do is we perceive objects in their entirety, and once we have done that, we are able to group the entire object. Then we identify its individual parts or subgroups. So the question really is, how do we accomplish this? What are the principles or rules that we use to achieve this? So I'm going to share with you some of these principles that have been summarized very nicely by Todorovich, and these are just a small collection of the larger set of rules. But let's start with proximity first. So if you look at the first row right here, this piece, this visual, we can see this entire collection of elements as being a group. And all of these 6 elements belong to the same group. And if you change the distances between the elements as such in the second row, you still can see this entire set to be one group, but now you see the emergence of 3 subgroups. And these subgroups emerge because you've changed the proximity or the distances between the elements. And now you can change the distances as such, and this is a different perception of the subgroups. Still, proximity dominates here in that you would characterize these 2 as being a subgroup and not these 2. So that's proximity. That's one rule. Closer objects are grouped together, not surprising. And then you have similarity as a principle. In this case, things that look the same are grouped together. So once again, in this case, you can see this whole thing as one group with these subgroups, and the subgroups are defined as pairs that actually look identical to each other. In this case, you have these 2 that look identical to each other, but now you have similarity and proximity sort of fighting against each other. Are these 2 the same subgroup right here? Or is this a subgroup? And perhaps proximity begins to win out in this case. You're willing to see this as a subgroup. So that's the similarity principle. Then you have common fate. You may have things that are pretty far away from each other, these elements, but if the same thing happens to them, then you see them as one subgroup. So for instance, in this case, you see that you have these elements that are not really that close to each other, but they're moving the same way. By the mere fact they're moving the same way, they have common fate, so to speak. Therefore, they are immediately grouped together as a subgroup. So that's common fate. And then there is common region or connectivity. So in this case, if you have a closed region right here, you put a boundary around this, this becomes a very strong cue that this is one group, subgroup right here, this is a separate subgroup. Even though the distances, in terms of our proximity principle, the distances between all of these are the same. And if you have links that connect these elements, then that's yet another way to group, that we use to group things together. That's a very strong cue that this is a subgroup, and this is another subgroup right here. So connected objects are grouped together. And then you have continuity. In this case, you're looking at alignment or orientation of these elements or how they're moving. So these elements that happen to lie what appears to be a single smooth curve, they are grouped together as a single subgroup and different from this group right here, which is moving in a different direction. So features on a continuous curve tend to be grouped together as a subgroup. And then finally, you have symmetry. So symmetry is a very strong cue because you can imagine it's very unlikely in a scene for two things to be symmetric in some way and not belong to the same group. It's just the chance of that happening is just very low, that things would actually align in this perfect symmetric way. So therefore, symmetry is a very strong principle that we use to group things together. These two, for instance, these two, and the same with this. And the same applies. There's different types of symmetry, as you know. So the same applies to these subgroups here as well. So parallel and symmetrical features are grouped together. And finally, there's also illusions related to grouping. So we've discussed the Canizza triangle. So in the case of the Canizza triangle, we end up seeing a bright triangle in the center here. Well, in this case, we know that in terms of pixel attributes, these pixels are identical to the pixels that lie outside the triangle. But we are imagining a triangle here. That's because of things that we have seen in the past, familiar things. In this case, we imagine a sphere right here, and so on. So illusory or subjective contours are also perceived to complicate things further. And finally, the point that I want to make is, and this is some work that was done by Martin et al. At Berkeley, that image segmentation is highly subjective by humans. So here's an image, and these are three different people that were asked to come up with meaningful regions or segments in these images. And these are the segmentations they came up with. These two actually look pretty similar, but look at this one. It has a lot more smaller regions that were deemed to be meaningful. So this segmentation is quite a bit different in terms of detail from this one. So this is to say that segmentation is highly subjective. Perhaps better demonstrated by this example right here. In this case, one user simply sees this as being two segments. That is, there is a line that just partitions the image into two meaningful regions, which is two people. In the case of this user, the hair is a different region from the face. In this case, he or she sees these decorative pieces in the background as being separate regions or meaningful regions as well. So highly subjective. So all this to say that we use our own intuitions and experience for segmenting images, and it's also very hard to translate these intuitions into a single algorithm. We don't fully understand them, we don't even agree on them. And so we can say that there are two approaches one could take to the segmentation problem. The first is what we'll call the top-down segmentation approach. This is more in line with the Gestalt approach, where pixels belong together because they come from the same object. Once you're able to identify that, then you can go in and look at the parts of that object. This is a hard problem to solve. We don't yet know how to solve this except for specific classes of objects. The other approach, the simpler approach, is the bottom-up segmentation approach. Here, pixels belong together because they simply look similar. This is something that we know how to define and develop algorithms for. And this is the approach to segmentation that we're going to take.